Good morning, ladies and gentlemen, and I'd like to introduce Dr. Stephen Hamill, who will be presenting an introduction to the NBS National BIM Library. Please take your seats at the NBS Bite-Size Theatre, and thank you.
Yeah, thank you, Paul. Hi, my name is Stephen Hamill, and I'm Director of Design and Innovation at NBS. And for the next 15 minutes, I'm going to talk about the National BIM Library. The National BIM Library is an initiative that we launched at EcoBuild last year, and it's about producing standardized BIM objects that are free for the construction industry in the UK. We've got about 600 objects live now. 400 are generic. So that's where no manufacturer is mentioned, but they've got standardized property sets behind the scenes. And then we've got about 200 now that are proprietary. So manufacturer objects representing the actual manufacturer performance properties, operation properties. What I'm going to do today is not open up PowerPoint, but I'd like to just play around with some of the software and sort of see where that takes us. So what we're looking at the screen at the moment is a package called Autodesk Revit, but the objects also come for Bentley, AutoCAD, Vectorworks also. And we can see on the screen quite a simple building, sort of 1 story high, and this has been put together, designed using the National BIM Library components. So it's a sort of restaurant that you maybe find at the side of somewhere like Centre Parks. And what I'm going to do is just take a little cut through the object so we can look at the objects inside. So I'm going to come along now into the 3D view and just put the section box up. And you can imagine this is a cake that I'm slicing through. And I'm going to grab a hold of the sort of knife and slice through this building. And then I'll just zoom in here to this particular part. I think it's the washrooms. And you can see that this is actually made up of objects. So you can see a floor covering object there. We've got partitions, ceiling constructions, sanitary ware, doors, windows. So in terms of those 400 generic objects, it's all of the main sort of building fabric objects that an architect would design a building from. And in terms of that object development, you can start off with a concept object. So things like a concept partition, a concept floor, to define the shape of your building, what the spaces will be in it, what the sizes will be, but without necessarily deciding what's actually the fabric of those sort of layered objects. When the design develops, at that stage you can swap for the actual materials that are inside. So if you look at this particular wall, this is now, we know it's an internal wall, plasterboard gypsum with 140mm block. And if we have a little look inside it, you can see there's the sort of structure where you've got some plasterboards, blockwork, plasterboard. In terms of something like walls or partitions, we've got around 80 of these, the most commonly used ones in the UK. And by starting with that common sort of palette of tools, it means when the design team gets together, they can start using these on project to project. If you imagine design and build projects where the main contractor works with different consultants on every project, it means they're getting consistent information every time. It means when a cost consultant works with different design teams, again, they're getting consistent information. And that's just such a fantastic idea, as opposed to everybody doing it differently in every office around the country. This is where NBS first started in terms of specification. Back in the 1970s, everybody was doing specification differently. And the RIBA took a group of 4 architectural practices in the Northeast and said, come on, we shouldn't all be doing this differently. Let's have a standardized specification system. And 40 years later, NBS has developed to where it is at the moment. We're now doing this with BIM as well. So we've had a little look at layered objects. The basic concept of BIM is that you develop a 3D model, and then you can take cuts through it and display the information that you would like at that particular time. So here's a cut which shows the floor plan. Here's a cut where there's just different styles being attached, maybe some things made invisible, so you can just look at the floor coverings. And that's all generated from the central model. So if you change it once in the central model, it updates in all of your sections, your floor plans, your schedules. Let's just have a look at a fire plan here. And I'm just going to zoom into this area here, and we look at one of the National BIM Library doors. In terms of the parameters behind the National BIM Library objects, you can maybe group them into two broad categories. You've got the parameters that control the geometry, how it looks when you're doing your sections and floor plans, and the parameters that define the performance, such as fire rating, acoustic rating, surface spread of flames, etc. And all of those parameters come from a standardized sort of global template. And that's the same naming convention, whether it's Autodesk Revit, whether it's Bentley, whether it's ArchiCAD. So when you get federated models that come together, it's the same consistent naming throughout. So let's have a look at some of the geometric parameters. Let's say on this particular door, you want to have architraves on the front and the back. It's just a simple tick of the checkboxes on the left-hand side, and you see that visually on the floor plan, it now adjusts. If I'd like to change the opening angle of the door, I can drop down a little bit here and change. So it's quite tricky to do with the mic. Change that to 90, and what you can see is the doors instantly change from indicating 45-degree opening to 90-degree opening. The thinking that's gone into those geometric parameters has been months and months of work. So if I actually look at the rules behind the scenes and come into the family editor for this door, you can see a little bit of how it's been constructed. So we've got vision panels that align to the British Standard recommendations. And if I look at the parameters behind the scenes, you can look at some of the equations. Just something like, what have we got here? The clear opening width. You can see how it's been defined in terms of that's a combination of the structural opening width, the structural tolerance, the frame thickness. And that's been developed talking with some of the leading door manufacturers in the UK. So we've got fantastic objects there, whether that's doors, windows, sanitary ware, signage. Each object, which is free to download from nationalbimlibrary.com, also comes with the help guide. So if I jump across here now, I'm not connected to the internet, but you can see we've got a 25-page manual, and that's there for every object. So free to download, you can get the objects in multi-formats and the associated help guide, all completely free for the industry. Okay, let's just jump back to the software again. And I'll close the sort of family editor. Most people don't have to open family editors. You can just use the objects with the nice functionality. Let's look at this door again and look at some of the performance properties. So when we talk about BIM, we really want to focus on the eye of BIM, the information behind the scenes. And if you look at the parameters over and above the geometric parameters, you can see what we've done. We've gone to the international standards, IFC, as defined by Building Smart. And we've used all of the international standards for things like smoke control, acoustic rating, security rating, thermal transmittance, fire rating. And that means it's consistent. Instead of getting a door out of the box with Revit, downloading one off the internet, someone in your office creating one, and all of that terminology being different, you do your door schedule and the fire rating's all squiggly and has to be pulled back together, you've got a standard set. And that means when you do your analysis, whether you're analyzing the building for environmental impact or cost or performance, you've got those standardized property sets. So here's a kitchen that we're looking at. And what you can see here is a very simple performance analysis. When the fire rating is 60 minutes, the elements color blue. When it's 120 minutes, they color red. And around the kitchen, you might want a 2-hour fire rating. And you can quickly glance here and see that this particular door is being specified incorrectly because it's colored blue. So what I can do is select the door, jump down to the fire rating with one hand. I need a helper, I think, so I come down, there's fire rating, and I'll change change that to 120, and you can see the blue door is now changed to a red door, and that information's clearly labelled. And I know this is a very simple building with one floor, it's not particularly big, but on a large development, that sort of ability to change consistent parameters and see that visually across the entire floor plan is big efficiency savings and solves problems that may appear later on. I know it's a quick 15-minute presentation today, but with similar things for windows, quite nice fire signage. One of the bits of functionality on the signage is that they're actual size when you see them in 3D, but when you look at them in plan, we've oversized them. So let's say you're the chef and you're cooking here, and you set the chip pan on fire. Where's the nearest fire extinguisher? You can't put the fire out. How do you quickly get out the building? And you can see the exit signs. Again, these aren't objects you've downloaded from America or Canada or New Zealand, where the signage is different. These are from the British Standard official sort of graphics. The reason National BIM Library is free is because it's funded by manufacturers. So we've got 13 manufacturer contracts in already, and we've got a number of manufacturers that are really keen to get on board. I think when I do this presentation again this time next year, that number of 13 manufacturers will have grown to maybe 50. And the great thing about the manufacturer objects, if I just I'll close this model and open a different one, is that the manufacturer objects come pre-populated with all of the actual sort of physical properties. So here's Kingspan insulation, and if I have a little look at the properties there, if you bear with me a second, you can see that's actually filled with all of the properties for that material. So you can see the global warming potential, the green guide rating, the standard sizes, standard length, width, thickness, all of the IFC performance parameters. And putting that information in just allows incredible possibilities on material takeoff, looking at the properties inside, recycled content reports, but also clever apps can be developed, just like you get for your iPhone. So the standard sizes, you could have an app that looks at the spaces in the buildings and tells you how much waste. You've just designed a certain room with a certain window layout. What's the waste in terms of foam board that's going to be going into landfill or back for recycling? And then you can adjust it at design time to really make those informed decisions. So using BIM to help reduce the environmental impact. So what I would encourage is when you do talk to manufacturers, and there's lots around here at EcoBuild, when they think about their manufacturer spend, their marketing spend, do you really want glossy catalogs? Do you really want 3 stories worth of standard EcoBuild? Or do you want high quality digital information that will help you design? And I think what we're going to see over the next year, 2 years, 3 years, is manufacturers realizing that. And just how architects have moved from drawing boards to computers, manufacturers will provide information in a structured format for designers to use and make informed decisions to produce more efficient buildings, cheaper buildings, buildings that get built quicker, and also buildings where the environmental impact is reduced. As with the generic objects, each manufacturer object comes again with the user guide. So jumping across here, there's a user guide for CalZip, and we go down, and it tells you again all the naming convention, all the properties that are used, and how those properties relate to the international standards, such as IFC 2x3, and also the UK government COBE 2012 standard. So what I'm going to do now is, I'm not sure how many people were here for the NBS Create presentation that preceded this, but I'm just going to show how the objects in a sort of 3D BIM in design tools such as Revit link across to the specification system. I am aware I've run out of time, pretty much, but I think I'm going to keep on talking anyway because the next presentation isn't until 12 o'clock. So unless Paul drags me off, I'm going to keep talking. So what I'm going to do now is open up a simple building. So this is one that I've just designed myself with my sort of rubbish design skills, and just put a few objects in just to demonstrate how this sort of 3D BIM model links to specifications. what we can see, all of the National BIM Library objects inside here are classified using the new Uniclass 2 object classification system. So if I have a little look at the properties behind here, I can see that 25, 50, 20, 120. Now by having a common classification system for objects, it means that all of these databases can now talk to each other. And an example of that is with this simple button at the top. So we talk about clever apps. Here's a little app which fits into Autodesk Revit. We've got apps also for ArchiCAD. There's one getting developed for Vectorworks. And I can click this button and just create a specification. So again, one-handed. So I'm creating a specification called EcoBuild 2. And when I click the Create button, what it's going to do is analyze that design model. And every time it finds a type object, it's going to download the very latest version of the NBS Create specification clause. So it finds 3 different floor covering systems, a ceiling system, partitions, landscaping, hard landscaping, turfing. And for each one it finds, it's actually creating an outline spec that's ready now for the specifier to complete. So it's almost there now. When that progress bar hits the end, you get the confirmation. So I've just created an outline spec with all of these items in. If you want to jump across and see them, it links with the model itself there. There's the turfing outside the house. If I wanted to see the concrete floor, there's the concrete floor, which sort of underpins the entire building. But when I jump across to NBS Create, our specification system built for BIM, I can now open that specification, EcoBuild 2, and see all of those objects inside it. And then it's just a case of opening them. So there's my partition system, and you've got that checklist of clause, checklist of options that people have always valued NBS for, where you can go and build up the specification now. So here's the questions. Do you need a damp-proof course? Expert technical guidance synchronized on the right-hand side. And depending on where it is in the building, what sort of project it is, I can make the correct decision. And what that does there is bring the very latest version of the product clause in. And I can go through there now, and what sort of framing would you like? I'd like a wood frame. Talk about the linings, the joint treatment, the finishes, what the tolerances are, what the workmanship is, what accuracy, what the quality of goods should be when it arrives on site. Really plugging that gap that's there at the moment, which is the information in BIM. When people talk about BIM at the moment, I think they're talking about 2 or 3 things. They're talking about drawing generation, creating schedules, and sometimes, where they collaborate, crash detection. But linking it to the specification, this allows us to really focus on the I in BIM, information in BIM, and to coordinate what's in your drawings and schedules with what's in your specification. The last thing I'm going to demonstrate here is how, when things change in the specification model, you can bring them back into sync with the central BIM. So a very simple example. I'm going to just put a few annotations inside here. So I'm just going to annotate the bath, the wall, maybe the sink, and some floor covering system. And just demonstrate what happens when things change in the specification. So I'm going to come to the bath and just change the name. I'm going to call it a bath system as opposed to assembly. And what I'm going to do is get rid of this carpet system. It was too expensive. And add a different carpet system. So I've got rid of an edge fixed, and I'll put a rolls carpet in instead. So we've got a problem now, because what it says on the drawings and schedules is different to what it says in the specification. And that's where problems occur on site. Somebody buys the wrong product, it gets installed, who's going to pay for it? Is it the design team? Is it the contractor? Is it the client? How much money are the lawyers going to make? And we can try and avoid that now by having clever software and objects that are linked between different systems. So I jump back across to Revit and I say, give me a report on all of the linked objects. And it goes through every single object in the Revit model, compares it with every single object in the specification, and it just pops up a little report and tells you that 14 objects are fine. So the partition system's fine, the ceiling's fine, the turfing's fine, but we've got 2 problems. And the first problem there is the carpet system that's been removed from the spec by Jimmy on a certain date, and the bath assembly is just coming up as a warning because it's just the title that's changed. And what I'm going to do here for the bath is just pull the latest title through, and you'll see the bath assembly changes to bath system. And that wouldn't be done just on that floor plan, but every single time that bath is referenced. So in your multi-category schedules, in your sections of the washrooms. And what I can do for the carpet system, it's slightly more complicated. I've got to actually just jump into the specification and find the new item. So I might want to shout across the office and get the guy that's writing the spec to stand with me, and maybe as an architectural technician I can sit there with the specifier. Just got to find where it is. Find the new carpet system, and it's a single click, and you can see there it just brings everything back in line again. So what we're seeing there is standardized objects that can be used when people are building modeling at the moment. You can go to nationalbimlibrary.com, use these objects and have standardized objects used for buildings. All the consultants working together. We're working very hard this year, and we're going to try and match the 400 objects we've got for building fabric with another 400 objects for service engineers, and we're really going to push the manufacturer content again this year. But where you can get the real benefit is if you link the information in your models with the information in the specification, where the real detailed information is. And you can have the main model working with the specification model, and then coming together, generating your COBie output, your IFC output in a really rich format. So I've gone off in different directions there, didn't want to use PowerPoint, and I think I covered everything I wanted to talk about. But thank you for your time, thank you all for listening. If there's any questions, please fire away. Thank you.